Hi, everyone. So this is lesson 9, factoring quadratics with special cases. And what we're going to be looking at in this lesson is two special cases that if you recognize are there, make your life a lot easier. And those two special cases are what we call perfect squares or difference of squares. And I'll explain what those are. But let's just take a step back for just a second and review what we've been doing. So this whole second part of Unit 4 has been something called factoring. And really, what we're trying to do is move from standard form over to factored form, okay? And we've got these different techniques for doing it. And so that's what we're going to learn another one of those techniques today. So, you've done the simple trinomials, which are just a simple x box. Last lesson, you did the complex trinomials, which involved a few more steps, but involved the x box as well. And today we're going to learn the last thing, and that is this idea of perfect squares or difference of squares. Okay, so let me just, let's get going with this. So the first one we're going to do is something called perfect squares, okay? And again, my hope is that and you're going to see in the next lesson, I'm going to give you kind of like the steps that you will do. But one of the things that I'm going to have you consider is, are these perfect squares? And so what I mean by that is the first term and is the last term, are they both what we call perfect squares? In other words, there's a number that when multiplied by itself will give you that term or a letter. So look at this one. What I'm going to show you here is that if you can quickly check this, is there something when multiplied by itself that gives you that first term? And the answer is yes. And the answer is x, because I know that x times x is x squared. I also see that 9 is an example of a perfect square, because 3 times 3 will give you 9. Okay, so look at this. This is setting up really nicely. The only last thing you have to check is that if you take the number or the letter here and multiply it by the letter here or number and multiply it by 2, if that equals this middle number, so look what I'm going to do. I'm going to show you 2 times x times 3 equals 6x. Because look, 2 times x is 2x, and then 2x times 3 is 6x. So this one qualifies. This is what we call a perfect square trinomial. And as soon as you see that, basically you know that this one in factored form is going to be x. It's going to be this value plus this value, and then just times itself. So this first one that you found, the second one, and then you just times them by each other. And the really nice thing is you can also write that as x plus 3 squared, because it's this bracket times this bracket, the same thing. Oh, so it's just x plus 3 squared. So what I'm showing you here is in letters what I've just shown you with numbers. So look at this. Notice that in this first term, it's a squared. The last term is b squared, and I'm just using those to represent letters or numbers. The middle term is just 2 times a, which remember is the square root of a squared, and times b, and b is the square root of b squared, and you get a plus b, or a plus b squared. Okay, I know that seems like a lot, but let's try another one, and I think you'll see what I mean. All right, here we go. Okay, so how about this one? So again, we're trying to write this in factored form, and we're considering whether this is one of our special cases. So look at this. Is this whole first term, is it a perfect square? And I notice that it is. Look at this. 49 is 7 times 7, and x squared is x times x. So look at this. That first one is 7x. That's essentially the square root of both of those values, 49 and x. And look at the last term. It's 16, and so that's 4 times 4. So this is shaping up to be what we call a perfect square trinomial. I just need to double check whether or not this middle term is going to be 2 times 7x times 4. So here we go. 2 times 7x times, times 4. Let's try this one more time. Here we go. Times, come on, times 4. Okay, here we go. So 2 times 7 is 14x, and then times 4, oh good, yes, it's 56x. So look at this. This is a perfect square trinomial. So technically then, in factored form, you take this value and this value. I'll just write them as, I don't want to write them as A and B because I don't want to confuse people. Look at this. It's this first value and then the second value, and we write it as 7x plus 4 times itself, 7x plus 4, or 7x plus 4 squared. Okay. This next one is very similar, except notice that there's a negative sign in there. So that just, you got to be careful. So I'll show you what happens in this situation. So here we go. Let's do this one. So first of all, is the first term a perfect square? Sure it is. It's x. Is the last term a perfect square? Sure it is. The square root of 25 is 5. Okay. But then look at the middle term. Is it 2 times x times 5? 2 times x times 5. Sorry, that's not very nice. I'm going to fix that up. Here we go. Is it 2 times x times 5? Well, it's so close to that. It's minus 2 times x times 5, and that's minus 10x. So if that's a negative sign, look what you can do. It's going to be very similar. Instead of it being x plus 5 squared, it's going to be x minus 5 squared. So look at this one. This will be x minus 5 times x minus 5, or x minus 5 squared. So just be careful. If you have a negative sign there, it may not be. Notice on the previous two, they were both plus signs. So here we had x plus 3 squared, and then here we had 7x plus 4 squared. But here, because of that negative sign, we have to change this one to a negative, and it's x minus 5 squared. Okay, let's do one more of these perfect squares. So we look at this one, and we say to ourselves, okay, is the first term a perfect square? Sure it is. It's the square root of both is 2x, and this one, it's 5. And so we double check. We look here just to make sure, is 2 times 2x times 5, does that equal 20? Sure it does. So this is a perfect square trinomial, and therefore we take these two and we just go 2x, and then because that's a plus sign, it would be plus 5 times itself, 2x plus 5, or it's 2x plus 5 squared. So it just makes your life a little bit easier if you do that. Now, one thing I wanted to show you with this is I just wanted to show you that even if you didn't catch it and you had done it, as a complex trinomial, you'd get the same answer. I'll just show you this. Let's say you were doing 4x squared plus 20x plus 25, and you didn't recognize that the first term and the last term were perfect squares. In other words, they're both even square roots. You didn't recognize that. And so let's say you charged ahead as if this one was a complex trinomial, because you can see that the A is 4 and not a 1, and B is 20 and C is 25. Okay, well, let's say here we would go. You would start your X box and do 4 times 25, and 4 times 25 is 100, and then you'd put your 20 down here for your B, and then you'd start looking for two numbers that multiply to 100 and add to 20. And hopefully what you see is that you get plus 10 and plus 10. Okay, so then what we would do is we'd bring those numbers over and we'd go 4x squared. I'm just doing the steps of a complex trinomial. So plus 10x plus 10x plus 25. So we took those two and broke up that middle term. Okay, these are the steps. Now what we did is we factored the first two terms. And so we said, well, that's 2x times 2x plus 5. And then we rewrote that same bracket here. And then we were looking for a number here that when multiplied into the brackets would give us these two terms. And I see that it's plus 5. And then we put it all together and you get 2x plus 5. We put this and this together. And then we just pull the other bracket down. There it is. But look at this. We get the same thing as we did here, which is 2x plus 5 times 2x plus 5. Which is also equal to 2x plus 5 squared. Okay? So you get the same thing. It's just that this way, if you recognize that you have a perfect square trinomial, it's a little bit easier to do it right off the bat. Okay, the other special case that we sometimes see in factoring is something called a difference of squares. Now, right off the bat, a difference of squares only has two terms. So notice that it's a little bit different than the trinomials we saw because these ones only have two terms. Okay, so that's one hint that you might be dealing with the difference of squares. And what I'm going to tell you that you'll see with these difference of squares, you're going to see that both the first one and the second one are what we call perfect squares, or they're even square roots. In other words, there's a number that when multiplied by itself will give you that number. So sure enough, look at this. The first one is x, and the second one is 5, because 5 times 5 is 25, and x times x is x squared. And here's the critical thing. They're separated by a negative sign. So they must be separated by a negative. So if that's the case, if they're both even square roots and they're separated by a negative, then the answer is this. It's simply going to be this value plus this value times this value minus this value. So look at this. It's x plus 5, x minus 5. There you go. That is what it is, and that's what I'm showing you over here. This is the general case of it. Basically, it's if you have two what we call perfect squares that are separated by a negative, so that's why we call them a difference of squares. You simply take the square root of the first one and the square root of the second one and go a minus b, a plus b. That's it. Let's try a couple more. So here, I'm just going to make these a little bit bigger. Okay. So look at this. Look at the first one. So for the first one, it says 81x squared. So I look at that and I say, well, first of all, I see the two terms and I think, oh, maybe this is one of those difference of squares. And sure enough, 9x times 9x is 81x squared. And then here, 4 times 4 is 16. And look, they're separated by a negative sign. So the answer is 9x minus 4, 9x plus 4. And look at this, you guys, just if you want to verify for yourself, watch what happens. If I were to FOIL this, I would do first, 9x times 9x is 81x squared. 9x times plus 4 is plus 36x. Minus 4 times 9x is minus 36x. And minus 4 times plus 4 is minus 16. Notice that those two terms disappear, and you're left with 81x squared minus 16. So there you go. This one's in factored form. That's what this one looks like. Okay, how about this one? Now, one thing that we've kind of got away from, and I wanted to emphasize this, is that the very first thing you should be doing anyways is looking to see if there's something you can take out. And so I'm hoping that a lot of you will look at this first one and say, well, wait a second, Mr. Webster, 5 can go easily into both of those things. It would be 4x squared minus 1. And then look at this. This first one is a perfect square. So look at this. I can do an even square root, so 2x, because 2x times 2x is 4x squared. And look at this. 1 times 1 is 1, and they're separated by a negative sign. So therefore, this one in factored form is 2x plus 1, 2x minus 1. There you go. So that one's that's the difference of squares for that one. All right, so can you practice a few of these? Here's a quick summary of them. And then here are your homework questions. And I'm going to get rid of, I kind of had a look at these, and I'm going to get rid of number 11. It's just an interesting application, but I don't think you need it. So I'd like you to try these ones. These ones are all look like they're all difference of squares. These ones look like they're perfect squares, and these ones look like a combination. And then the answers are given here on this page. One final thing I forgot to mention is if you get something like this and it's not a negative sign between them. So let's say you had x squared plus 16. People might think, oh, wait a second. I'll just put here, it's another example, is that they say, oh, well, that's x times x, and that's 4 times 4. So that one is x plus 4, x minus 4. It's one of those ones. Well, no, it's not. It's not, because this has to be a negative sign for that to work. So please, if you get one like this, it is not a difference of squares. It only works, and I'll make a little comment here, it only works if the two values are separated by a negative sign. Okay, so just be aware, because that one was positive, there are no roots for that one. Okay, so give those homework questions a try and we'll go from there. Thanks.